Let's talk about concentration. Okay, you were supposed to read through this and answer 2, 3, and 4. So number 2, it says a mass of 25 grams of sugar is dissolved in 150 cubic centimeters of water. What's the concentration in grams per cubic centimeter, grams per 10, and grams per 100 cubic centimeters? This is not multiple choice. You got to solve for 3 different amounts. So on number 2, letter A, to find grams per cubic centimeter, use this equation. Concentration is just equal to mass divided by volume. Or we can say concentration is equal to 25 divided by 150, where the concentration is 25 divided by 150, which is 0.17 grams per cubic centimeters are the units, because we've only got this many grams and this many cubic centimeters. Then on letter B, it's grams per 10. So to find grams per 10, we're going to take mass divided by volume times 10. So concentration is equal to 25 divided by 150 times 10, and you end up with a concentration of 1.7. Now the units are grams per 10 cubic centimeters. Letter C, they want to know grams per 100. So to find concentration in grams per 100, we're going to say mass divided by volume times 100 is going to give us grams per 100. So concentration is equal to 25 divided by 150 times 100, which is 17 grams per 100 cubic centimeters. This is going to be our standard unit for both concentration and solubility. We'll deal with solubility probably tomorrow, but all that solubility is the maximum concentration, the maximum amount of substance you can dissolve in a liquid. So number 3, which solution is more concentrated? 2.5 grams per cubic centimeter or 2.6 grams per 10? Our problem here is we've got 2 separate units. So let's make them the same unit. If we just take, if this much is dissolved in 10, if we just take this divided by 10, we can have both units in grams per cubic centimeter. So if we take 2.6 grams divided by 10 cubic centimeters, you get 0.26 grams per cubic centimeter. So which is more concentrated? 2.5 grams in every cubic centimeter is more concentrated than 2.6 grams dissolved in 10. Number 4, which of the following steps will increase the concentration of a solution of salt and water, allowing some of the water to evaporate? Well, let's look at it. Concentration, let's just say it's equal to mass divided by volume. If you allow some of the water to evaporate, you're going to decrease the volume, and you're going to therefore increase the concentration. Adding water to the solution. So A should be circled. If you add water, same equation. You're now increasing the volume, which is going to decrease the concentration. So B should not be circled. Adding salt to the solution. If we add salt, you're going to increase the mass. If you increase the mass, you increase the concentration. So C works. Pouring out some of the solution. If you pour out some of the solution, you're going to pour out an equal amount of mass. That's going to decrease, and volume is going to decrease, and it's going to leave the concentration exactly the same. So those should be your 3 answers to 2, 3, and 4.